I'm back. In this video I'll be solving little problem 239, sliding window maximum. So we are given an array of integer numbers. There is a window of size k which is moving from the very left to the right. You can only see k numbers in the window. Okay, so we have a sliding window, in this case of size 3. We take the max of these. Let's see hints, because I'm not sure. How about using this as deck DQ? Okay, I think the hints are good enough, so let's use double-ended Q. Guess this. Pull left, yeah. So what do we do? We'll use Q. So we put to the Q only if it's so we have these three in example. When we build up to this window, we go 1, we put 1 in the queue. When we get to 3, if 3 is bigger than what we have in the queue, then we put a 3. And so on. If what we found was less than 3, like in this example, so in this example, when we actually even here we'll put -1, because we don't know when we go here will -1 be there, but if we get anything that is bigger, we'll just remove it. So essentially that's the logic. Okay, so output so for I in range, sorry about that. Just check it for a second. Okay, so I'm back. So for I in range length of nums, so if so I have if q of 0 is less than q of 0 is less than, well, there is actually two things I do. So either I remove let's do it like this. So if I is greater than k, then I do q dot pop left. I remove the left element. And either way, and then while q of 0 is less than I guess nums of I. Well, if well, actually, I can just remove it and I can just add it. So q dot add, either way I add it, nums of I, but while q of 0 is less than nums of I do q dot pop left and output of 0. And actually I do not do this, so I actually do not do this. So if I is greater than k, 0, 1, 2, 1, 3, okay, greater, equal. I don't do actually pop left, but if, well, if nums of I minus well, either way I have to pop, so let me think about it. Or do I? Well, if it is, then I should remove it. So if nums of I minus k is equal to q of 0, then I do q dot pop left, I think like this. And if it's not, then it was already removed. Nums of I pop left, and then I take the last element and append it to the q, and I return out. I think something like this. Okay, then append, I guess. And yeah, we don't, but I don't output. I only output if I is greater or equal k. Then I do this. Or how am I missing one element? So I have 3, 5, 5, 6, 7. I have 3. Well, why did I already remove it? Well, when it was 3. When I was 3, there was 4 elements. So if on the top of the queue there is something that I already saw. Well, if k is equal to, yeah, actually k minus 1. This is the issue. Hopefully, well, it doesn't work. So it's 3. And then again, it's okay. I can clean it also. Maybe that's my bad. So while q of 0 is less than nums of I, or while q of minus 1 is less than nums of I, pop. I think I'm close, but oh, but I should have, yeah, this will never happen. So I have to do it here. Like this, index of range. Well, yeah, I should have appended the first one. Well, I want to first pop. Well, Q and maybe this. Yeah, nice. Okay. Well, it's not monotonic stack, but it's something monotonic in a way. But yeah, kind of unique approach. Space complexity of, and I guess worst case, and time complexity also often. So yeah, at most 2 times we'll go through each element. So how to add for this one? It's kind of weird, but yeah, it's kind of weird, but good example either way. Pretty good example. And it's possibly kind of famous because it's an early example of Leetcode problem. But yeah, hope this was kind of helpful. Yeah, if you have any questions, leave them in comments. I appreciate you following this one and see you in the next video.